So today we're going to continue with chapter 8. We're going to cover lesson 7. And in this lesson, we are going to define a function by using equations. So what we've been seeing in the slope-intercept form and the different equations, we were given things that look like y equals, and then maybe it had x plus 1. Now what we're going to be introduced to is function notation. And they're going to be using a letter. So for example, you might have something like f of x is equal to x plus 1. So this function notation is just this fancy way of saying y equals. And what's going to happen is when you get into, say, Algebra 2, you're going to be graphing more than one line on a coordinate plane. And instead of having to write out the whole equation, you could just label it with f of x or g of x. And they'll just pick a different letter for the function. So we've seen domains back in the beginning where they told you the values that they wanted you to use. And that's what we're going to be doing today. They're going to give you a function, and then they're going to give you domain values, and then you're going to plug them in. And then you're going to get the y value or the function value. So again, they're showing you different ways that you could write these. Again, the domain is always x, and it's what you're plugging in. The range is the value of the function or the y value. And here they're showing arrow notation and function notation. You won't really see arrow notation very often in the courses you take here. What we're going to use is the function notation. And the number or the letter in the parentheses is what you're going to substitute, or the variable in your problem. So again, you could read it as P of n, like here, P of n equals 5n minus 500. Or you can also read it as the value of P. But generally, you're going to see P of n. That's how you'll read it. So here, they're using the arrow notation. They could also have written it as g of x, and they'll do the parentheses, and then equals, and then they would write the equation. So 4 plus, or the expression that they're asking you to plug it into. So when you get a question like this, all they want you to do is take all of these x values and plug them in and follow order of operations. So for example, on the first one, I'm going to take away all of the variable x. So 4 plus 3, and now in place of x, I put -1. And then the same thing here. I'm going to leave the exponent. I'm leaving the subtraction sign, and then I'm going to plug in parentheses for the x, -1, and then the square stays there. So now I have to follow order of operations. So I'm going to evaluate the exponent first. So let me come over here now. So I'm going to rewrite the 4. I'm going to leave the 3 times -1. I'm going to leave the subtraction, and I'm going to evaluate the exponent. So this is actually going to become a +1. Now I'm going to do the multiplication. Now if you don't want to put the plus minus and put the 3 in parentheses, you don't have to. You could leave it like this. And now that the only thing I have left is subtraction, I'm going to just work left to right. So I'm going to come across here, and I get 4. Let's see what happened here. So 4 minus 3 is 1, minus 1, and it's 0. Then the next one, you're going to plug in 0. So this is what I mean by it's tedious. You're going to take the problem, and now you're going to show this work and how you're going to plug it in. And here, 4, and then 3 times 0, and then minus the 0 squared, and you get 4. And you're going to keep repeating this for however many domain values they give you. So over here in 0, you could put 4. Over here, this is going to be the 0. And then you're going to repeat it again and plug in 1. So 4 plus 3 times 1 minus 1 squared. You can multiply, do the exponent, work left to right. So 4 plus 3 is 7, minus 1, and it's 6. And then you're going to do it one more time. 4 plus 3 times 2 minus 2 squared. 4 plus 6 minus 4, and I get 10 minus 4, and again I get 6. So this would be the range values of what we just calculated. So the values of the function are also called the range values. Now, sometimes what they're going to do is they might just give you the function g of x equals 4 plus 3x minus x squared, and then using the function notation, they're going to say find g of 2. And then that's when you would do what we just did right here, and g of 2 you would say equals 6. So the number that'll be in the parentheses right here is what they're going to want you to plug in for the function. Let's try an example. So this is how you're going to see it in the homework tonight, a good portion of it. They're also going to give you domain values in set brackets. So again, if they have the function, the letter outside, and then a number in parentheses, that is the x value that they want you to plug in. So again, I'm going to do 3 different problems here. I'm going to first take the function, the x squared minus 2x. I'm going to replace both of these x's with a 4 the first time I do it. So 4 squared minus 2 times 4. 4 squared is 16 minus 8, and I get 8. The next one, x squared minus 2x. I'm going to do negative 3 squared minus 2 times negative 3. 3 squared, negative 3 squared would become 9. And then negative 2, treat this as a negative, negative 2 times negative 3 becomes positive 6. So for this one, I'm going to get 15. And then the last one, when we plug in the 2, 2 squared minus 2 times 2, 4 minus 4, and we get 0. So again, we're going to show our work. One wrong sign on this, and your answer is going to be messed up. It's pretty basic. You just have to take your time, watch your signs. Now, if it just says that the domain is this set of real numbers, then you can choose whatever x's you want to plug in. However, in this homework, they're giving you a set domain to use. So your homework for this is going to be 2 through 40 even. So just to go through some of these, let me show you some examples from each of the sections on what you're going to be doing for the homework. So for example, on number 1, the problem is, and they're writing it with the arrow notation. And again, we can change this to function notation. Either way, just be familiar with both ways of writing it. So all they want you to do is use all 3 of these domain values that are in the set notation or the set brackets, and you're going to do 3 problems. So the first time you're going to do it, x is going to be negative 1. The second time you do it, x will be 0. And then the last time that you do the problem, you're going to use 1 for the x value. So you're going to show that you're plugging it in. You're going to multiply and add. And then the first answer is negative 4. Then you're going to do it again and plug in 0. So 5 times 0 plus 1. 0 plus 1 is 1. And then again over here. 5 plus 1, and you get 6. So on questions 1 through 12 here, that's all you're going to do. You're going to plug in the 3 values they give you. You're going to show your work, and you're going to follow PEMDAS. Then the next page, when you're doing 13 through 28, you're doing the same thing, but now they're writing it with, like up to here, they're using the function notation, but again, the process is still the same. So instead of writing it in set brackets, they're writing it with the letter of the function and then the number they want you to plug in. So for example, on number 13, you're going to take 5x minus 9, and again, do 3 problems. I'm going to plug in for x 3, negative 3, and negative 8. So if I do positive 3, put it in here, follow order of operations, and then here I get 6. So that's what you're going to do here on 13 through 28. Even if it's the arrow notation, you're still just plugging in the 3 values. Notice when you get down here on these two, remember this is absolute value. So you'll do what's in the absolute value bars and then find the absolute value of your answer. Now, 29 through 40 is a little different. Now, it's got 2 parts. Part A, you're plugging in 0, which is the same thing that we've done when we did 1 through 28. So for example, on number 29, when I do part A, I'm just going to take and make x equal 0. So here I would take 3, plug in a 0, follow order of operations, and 29a's answer is negative 12. Now, for 29b, I'm going to set my equation equal to 0, and then I'm going to solve for x. So when you're doing part B on 29 through 40, what you're going to do is take the function, 3x minus 12, set it equal to 0, and now solve it. So I'll add 12. 3x equals 12. Divide by 3. X equals 4. So that's what you're going to do on that part. On any of the questions where it's got an x squared or an x cubed, like for this one, when I set this one equal to 0, I'm going to have to factor it. So let me show you number 35. So if I do the first part, I take x squared minus 2x minus 3. Plugging in the 0 for the part A is easy. You just put zeros, follow order of operations, and you would get 0 minus 3. In part A, the answer is going to be negative 3. But now, to set it equal to 0 for the part B, this is where we're factoring again. Okay, you're going to do a lot of this in Algebra 2. So I have to find the factors of negative 3 that give me negative 2. And those are going to be x minus 3 and x plus 1. So you're going to factor these into binomials when you have an x squared term, when you're doing the part 2. Then now we're going to set, because this is set equal to 0, set each one of your binomials equal to 0 and solve them. So here you would get x equals 3 and x equals negative 1. So however many, whatever the exponent is, that's usually a clue of how many answers you may have. So notice it was an x squared, so I have negative 1 and positive 3. That would be the answer to part B. So that's how you're going to do the homework tonight for section 8-7. Any questions?